Hey everyone, welcome back to the podcast. Today we're talking to Ben Gertzel, who's actually one of the founders of the AGI research community. He's been interested in this area for decades, really long before most people were. And he's done a whole bunch of interesting thinking around what it's going to take to build an AGI. We'll be talking about that a fair bit. We'll also be talking about his current AGI initiative, SingularityNet, which is taking a very different and some might say radical approach to building AGI that differs considerably from what we see at DeepMind and OpenAI. Instead of focusing on deep learning or reinforcement learning alone, Ben's taking an approach that focuses on decentralization, trying to get different AIs to collaborate together constructively in the hopes that that collaboration is going to give rise through emergence to artificial general intelligence. It's a very interesting strategy with a lot of moving parts, and it's going to lead to conversations about AI governance, AI risk, AI safety, and some more exotic topics as well, like consciousness and panpsychism, which we'll get into too. So I'm really looking forward to having this wide-ranging discussion with Ben, and I hope you enjoyed as much as I did.
Hi, Ben. Thanks so much for joining me for the podcast.
Thanks for having me. I'm looking forward to the conversation.
Yeah, me too. I think actually one of the areas that I want to start with, because I think it's sort of upstream of a lot of other things, and it's something that people often talk about: when is AGI coming? What's AGI going to look like? What are the risks associated with AGI? But I think upstream of that is a separate conversation about what intelligence is itself, and that seems like a hard thing to pin down. I'd love to get your thoughts on what you think intelligence is and how you define it.
So I do think intelligence as a concept is hard to pin down, and I don't think that matters too much. I think, for example, life is also hard to pin down as a concept, and you could debate whether viruses are really alive or digital life forms or retroviruses are alive. And I mean, yeah, there's some things that are really clearly alive, and some things that it's much less useful to think of them as being alive, like a rock. And then there are things that are near the border in an interesting way. And biology didn't grind to a halt because we don't have an exact definition of life, right? And I think similar thing is true with cognitive science and AI. So I've gone through a bit of a journey myself in thinking about intelligence, but that's a journey that has made me, I guess, less and less enthusiastic about precisely defining intelligence as being an important part of the quest. I mean, when I started out working on the theory of AGI in the 1980s, I mean, I wanted to have some mathematical conceptualization of the problem. So I started looking at basically, okay, intelligence is something that can achieve complex goals in complex environments. And I think that it's in the spirit of what Shane Legg wrote about in his thesis, Machine Superintelligence. Much later, my conception was a little bit broader because he's looking more at sort of a reinforcement learning paradigm where an AI is trying to optimize some reward function. And, optimizing expected reward is only one species of goal achievement. You could say instead, I'm trying to optimize some function over my future history, which isn't necessarily an average of reward. And you can also look at multiple objective functions, and you're looking at, so Pareto optimizing multiple functions defined over your future history. And I think so going that direction is interesting. It leads you down some rabbit holes of algorithmic information theory and whatnot. Then on the other hand, you could look at intelligence much more broadly. So my friend Weaver, David Weinbaum, had a PhD thesis from Free University of Brussels called Open-Ended Intelligence. And he's just looking at intelligence as a complex self-organizing system that is, modifying and extending and transforming itself and its environment in a way that is sort of synergetic with its environment. And if you look at things from that point of view, achieving goals is one thing that happens in a complex self-organizing system of this nature, but the goals may pop up and then go and be replaced by other goals, and the synthesis and interpretation of goals is just part of the overall sort of cognitive self-organization process. So from that point of view, achieving complex goals in complex environments is part of the story. but it's not necessarily the whole story, and obsessing on that part of the story could maybe lead you in bad design directions. And you could look at the current focus on deep reinforcement learning and much of the AI community as in part being driven by an overly limited notion of what intelligence is. And of course, successes in that regard may tend to drive that overly limited definition of what intelligence is. Also, you can then go down the direction of, okay, how do we formalize the notion of open-ended intelligence? And you can do that. And Weaver in his thesis wrote a bunch about, category theory, algebraic topology formulations. But then, I mean, that becomes a whole pursuit on its own. And then one has to think as a researcher, like, how much time do I spend trying to formalize exactly what I'm doing versus trying to do things and build systems? And of course, some balance can be useful there, because it is useful to have a broader concept of what you're doing rather than just the system that you're building at that point in time. On the other hand, again, going back to the analog with biology, I mean, if you're trying to build synthetic life forms, it is useful to reflect on what life is and the fundamental nature of metabolism and reproduction and so forth. On the other hand, the bulk of your work is not driven by that, right? I mean, the bulk of your work is like, how do I string these amino acids together? So I'm attracted by that philosophical side. On the other hand, probably it's best going to be addressed in synergy with building stuff. And it's interesting, when Shane Legg, who went on to co-found Google DeepMind, was working with me in the late 1990s when he was my employee in WebMind Inc. Shane's view then was, well, if we want to build AGI, first we have to fully understand and formalize the definition of intelligence. And he called it cybernance at that point. And then he published the thesis on machine superintelligence. And so he did, to his satisfaction, formalize the definition of general intelligence. Although I have a lot of issues with his definition, he was happy with it. Then shortly after that, he decided, but that's actually not the key to creating general intelligence. Instead, let's look at how the brain worked and follow that. So I guess each of us working in the field finds it useful to clarify in our own mind something about how intelligence works. And then you go off and pull in a whole lot of other ideas to actually work on it. Right?
Well, that's really interesting. And I think one of the things that's really fascinating about, I think, the approach that you're taking here is it's almost as if it implies that the moment we specify like a loss function, or the moment we get too absolutist about what it is we're trying to optimize, it creates room for pathology. Like, it creates room for an almost kind of ideological commitment to a certain loss function, which maybe we don't understand. Is that like
I mean, one thing you find in experimenting with even simple AI systems is, just like a computer program has the disturbing feature of doing what you program to do rather than what you wanted it to do. Like an AI system, given a certain objective function, it has the property of figuring out how to optimize that objective function rather than the function you hoped you were giving it, right? So I mean, it's common in game playing. Like if you set an AI to play in a game, I mean, it doesn't care about the spirit of the game, right? It's just trying to find a way to win, given whatever funny little loopholes there are in the rules of the game. And I mean, for a relatively simple game like chess or Go, it's all good, right? Because there's not that many loopholes. The board isn't that big. There's not that many pieces. If you're looking at a more complex video game, I mean, very often an AI will find some really insane, weird looking, like that can't work, right? But it does work, right? It's allowed by the rules of the game. And I found this playing with AI with genetic algorithms for learning strategies for games a long time ago, like in the 80s. I mean, as did others even before that. But that same phenomena, of course, occurs on a larger scale, right? And there's a whole bunch of complex papers looking at pathologies of you're asking an AI to optimize a reward, but then it finds some way to optimize that reward that wasn't what you're thinking. And this ties in with wireheading, which is talked about in the transhumanist and the brain computer interfacing community, right? So if your goal is to maximize pleasure, define the stimulation of your pleasure center, then why don't you just stick a wire in your head and stimulate your pleasure center? But that's very trivial, but there are sort of indefinitely complex versions of that pathology. That's not an easy problem, right? Because you can look at it like, if you look at the broader issue, so I genuinely want an AGI that I create to, in some sense, I want it to reflect the values that I have now. And even if I say I don't want it to fully agree with me on everything, I mean, the notion of fully agree, I want it to understand not fully agree in terms of my own mindset, right? Like I don't want it to like slice all my children into little strips and stir fry them or something, right? So I mean, there's a lot of things I clearly don't want to happen. There's some ways that I don't mind the AI leading me in a different direction than I was thinking, just as I want people wiser than me to lead me in different directions. But formalizing the wiggle room I want the AI to have in deviating from my values is also hard. And then, like, if I had an AI that had exactly the values I had when I was 20, I would be annoyed at that AI now, let alone the exact values that the human race had in 1950, let alone 1500, right? So you want the AGI, even if we had an exact formulation of our values, we wouldn't want the AGI to be pinned to that forever, right? Yeah. But then we want its values to evolve over time in synchrony with us, but we're evolving in directions that we don't know. So to formalize all that is infeasible given tools currently are at our disposal, leading one to think that formalizing these things is hopefully can't be necessary and can't be the right way to do it, right? And that leads you in whole other directions. Like, okay, if formalizing ethics and like pinning down an AI to formalized ethics and leads to all sorts of bizarre conundrums that are very far from resolution, maybe we take a step back and take a more loosey-goosey sort of human view of it, which is what we do with ethics in our own lives. And like if we take early stage AGI systems and we're relating to them in a way involving positive emotional bonding, if we have them doing beneficial things like education and healthcare and doing science and so forth, I mean, then are we qualitatively moving that AGI in a positive ethical direction rather than trying to approach it by formalizing our goals in some precise way and then guaranteeing that the AI won't deviate from goals except in the ways we want it to deviate from them, which we also can't formalize, right? So I mean, that's both satisfying and unsatisfying, right? But that seems to be the reality as I see it now.
And do you think, because there's a sense I keep getting from this, as you described, like our morality's shifted dramatically over the last 500 years. There are things we do today that we take for granted that would be considered morally abhorrent like 500 years ago.
Yeah, I mean, my mom is gay. She would have been burned at the stake, right?
Right.
I mean, clearly, and right now, I mean, I eat meat every day with some moral misgivings, but it's easy for me to imagine in 50 years, especially once synthetic meat is a thing that really works and almost works now. It's easy for me to imagine now that people will look back on eating hamburgers the way we now look back on cannibalism. And we're like, oh, but the burger tastes good. But yeah, I mean, the Stone Age tribesmen might have been like the other guy's upper arm tastes good, right? So,
right. And I mean, to the degree that like the cosine similarity basically between our moral fabric today and the moral fabric of like 1500s or 1300s Europe or wherever we've come from is basically zero. They're
not zero. Like kinship is value. We love our parents and our children. We love our wives, and we don't want to torture our own bodies. Like that, there is a core of humanity there. But the subtle thing is, what we identify as that core
Right.
is not what they would have identified in 1500. They would have been like, belief in God is the core, right? And to me,
Right.
I'm like, no, that was just some random nonsense you believed back then. That wasn't the core, right? So
And
it's
I guess we
yeah,
do have populations too that would look at, there are individuals within humanity who would say, it's morally bad to love your family. Like I'm sure you can find out of 7 billion people, a handful who would argue for that. Like I guess part of what I'm
of
wondering
course,
is
there are transhumanists
right.
who believe that, yeah, because that's tribal thinking, which is holding us back from moving on to a broader singularity where you're not clinging to all this DNA stuff. So yeah, sure.
So yeah, and I guess where that leads me is the question of like whether you think our moral trajectory, which is going to be, AGI is going to be a part of that eventually. But is that trajectory, like, is the process more important than the endpoint? Is it more about like the stepwise progression, or do you think that there's actually like a subset of moral norms that will be preserved throughout because they're intrinsically good?
Clearly, the process of transformation is a lot of what's important to us, right? Like if we could upgrade our intelligence at any speed, we would probably not choose to multiply our intelligence by 1,000 every second, because we would just lose ourselves. That's basically replacing yourself by a God mind, right? Which could be a cool thing to do. I mean, if it was like either I exist or the God mind exists, maybe I'll decide the God mind should exist. But I mean, if you doubled your intelligence every 6 months or something, then it would be more satisfying from our point of view of our current value system, right? Because we're getting continuity there. You're getting to experience yourself becoming a super intelligent God mind rather than
Right.
it just happening. And that, I think that has to do with why we feel like we're the same person we are when we were when we were like 3 years old. Like I remember back to around 18 months, but the sense in which I'm the same person as I was at 18 months. I mean, of course, you can cherry pick common personality traits there,
Yeah.
but the main thing though is each point I thought I was the same guy the day before and the day after, and just changed a little bit. And there,
Yeah.
even at a moment in your life when you have an incredible inflection point, right? Like I mean, in a few times in my life, I've been through some big sort of consciousness transformation where I felt like within a week I was a whole different person. But still, I didn't really think I was a whole different person, right?
Yeah.
I still realized that like it's still Ben. I'm just in a different state of consciousness. And that continuity is important to us on a cultural level also, right? So we and I think that will continue to be important to us going forward for a while. I mean, whether we will lose our taste for continuity, that's like a big question I don't have the answer for, right? You could imagine the taste for continuity continuously going down year by year until by like 2100 we're just a super AI mind who really isn't attached to itself at all. It doesn't care about upgrading its intelligence by a factor of 1,000 in a second, right? But now clearly we do care about that, and that's going to drive the progress toward the singularity in a number of different ways, right?
Well, and so speaking of progress towards the singularity, there are a number of different organizations now working on that big project. Like I think two of the most maybe high profile in the media are OpenAI and DeepMind. I know you've had a lot of influence on DeepMind in particular in terms of the folks who work there today in the thesis. But I'd love to get your sense of, so first off, what's your mental model of how OpenAI and DeepMind are approaching AGI? And then how does that contrast with the Singularity Net?
I mean, the first thing I would say is to me, putting those two in the same category is like putting, I don't know, Winston Churchill and Trump in the same category or something. I don't, they each have their own strengths, but I don't think those are really comparable organizations. And I think Google as a whole, and not just DeepMind, but Google Brain in the Mountain View office, which is where BERT and transformer neural nets, for example, came out of, and a whole lot of other valuable stuff. So I think Google as a whole has put together by far the best AI organization of any centralized company out there. I mean, there, of course, academia as a whole is stronger than any one company by a humongous amount in terms of coming up with new AI ideas. But if you're looking at a company or a government lab, a specific organization, I mean, Google has just done a really good job of pulling in AI experts from a wide variety of different backgrounds. So I mean, they have deep learning people. They've pulled in cognitive architecture people. They've pulled in a whole bunch of sort of algorithmic information people. They got Marcus Hooder, who's invented the general theory of general intelligence, right? So I think there's really a great deal of depth there. I know there's some internal rivalry between the Mountain View and the UK people, but I think DeepMind is very strong. Google Brain and other teams in Mountain View are also very strong. Google in New York area is very strong. So all in all, there's a lot of depth there, and there's a lot of different approaches being pursued behind the scenes, which are qualitatively different from the things that get a lot of publicity. So like my oldest son, Zarathustra, is doing PhD in AI for automated theorem proving, so machine learning to guide theorem proving. And his supervisor, Joseph Urban, is an amazing guy, organizes AITP, AI for Theorem Proving conference every year. You've got a bunch of Google DeepMind people there every year who are doing work on AI for theorem proving, connecting that with AI ethics and some of the things we were talking about earlier. And that's pretty much unconnected with video game playing or with brain modeling or the things that the Demis Hassabis personally is into. So I think there's a lot of depth there. They want to create AGI, like Larry and Sergey understand what AGI is and what the singularity is. Demis and Shane understand it very deeply. I think they are still at a high level. They're predominantly committed to deep reinforcement learning and sort of conceptual emulation of how the brain works in modern hardware as an approach to AGI. Now, they're clearly open-minded enough that they've made hires of great people who do not share their predilection, which is to their credit. But still, like, the vast bulk of their machine is deep reinforcement learning, crunching a lot of data on a lot of machines and trying to figure out what the brain is doing and figuring out ways to sort of do the same kind of thing in neural nets on a lot of GPUs, right? And so I think if that approach is going to work, it would shock me if Google weren't the ones who got there. Actually, I mean, I think, and now I happen to think that is not the best approach, which is a different topic, right? Now, OpenAI, on the other hand, I don't know them as well, but my wife, who's also an AI PhD, my wife and I, actually, I'm not an AI PhD, I'm a math PhD, so she's more of a certified AI expert than I am. But we went to OpenAI's unconference a few years ago in San Francisco, and it felt like a room full of super high IQ, brilliant, passionate, like 25-year-old guys or younger who thought, and mostly guys, literally, who thought that AI had been invented about 5 years previously, and that backpropagation was the only AI learning algorithm there. And like, there's a few guys there who were like, well, for our hackathon project this weekend, we're gonna enable natural language based authoring of Python programs, right? So we're going to train a seek-to-seek neural network to map NL into Python. After 3 days of hacking day and night, they're like, well, we found the irregularities in natural language are a bit more complicated than anticipated, right? Like these guys didn't know that they didn't know that linguistics or computational linguistics had anything to say, or they may not have known it existed as a field. Now, of course, I mean, Ilya Sutskever, of course, there were guys in OpenAI who were very, very deeply knowledgeable. But I felt at that stage, OpenAI was sort of like a deep neural nets only shop, and they were just hiring more and more people to bang on that, to use that one hammer to bang whatever they could, which is exact opposite of what what DeepMind and Google Brain have done. And then, I mean, the whole thing of GPT-2 is too dangerous to release because it's going to destroy the world. I mean, spouting bullshit is bad, but it's not going to destroy. It's not going to destroy the world, right? And that was invented in Google anyway. I mean, that's just
Transformer nets, you mean?
that's just yeah. I mean, that's just burnt in one direction, right? And so I mean, now actually, for some of my, I'm working on a number of things. I'm working on a bunch of AGI research that we'll talk about in a few minutes. And I'm also working on some applied practical AI projects. Like one thing we announced yesterday is a robot called Grace, which is an elder care robot, a collaboration with Hanson Robotics. And so that's supposed to go into elder care facilities and hospitals, provide social and emotional support, some practical functions. But in that project, like I want to launch that before I get to AGI. I need a practical dialogue system. I wish we could use OpenAI stuff. I wish we could use GPT-2 or 3, but a high percentage of what they say makes no sense. It's just bloviating bullshit. And then you can't put that in an elder care robot, right? So I mean, you see these things that they were claiming are going to destroy the world because they're so human-like. They're not good enough to use in almost any practical projects now. And I would say DeepMind has not done that either. On the other hand, GPT-2 I didn't mind so much because they hadn't gotten their payday yet, right? But now they're already bought by Microsoft. So why do they still need to overblow things? It's not financially necessary anymore, right?
And what is it that you think means that or prevents GPT-3 from performing at the level that it needs to? I mean, is it a symbolic?
It has no idea what it has no understanding of anything that it's talking about. It is my friend Gary Marcus, who's working with on robust AI with Rodney Brooks. He put it beautifully in his article, like GPT-3 bloviator, right? I mean, it just spouts stuff that sounds plausible, but it has no idea what it's talking about. And so I mean, you can see, like with multiplying numbers, it can do 2 by 2 multiplication. When you get up to 4 by 4 multiplication of integers, it's right like 15 or 20% of the time or something. That's just really, really weird. Like if you know the algorithm, you're right almost 100%, unless you make a stupid error. If you don't know the algorithm, you should be 0%, right? But what it did, it looked at all the multiplication problems online. It memorized the answers, and then it came up with some weird extrapolations that let it do a few problems that weren't in its training database, right? But it doesn't understand what multiplication is, or it would never get like 15 or 20% multiplication problems right. And you can see that in many other cases. Like you ask it, like, who were the best presidents of the US, it'll answer a lot of good things, then it'll throw a few kings of England in there just for fun. But I mean, because it doesn't know what of the US means. So the thing is, in the end, it has no more to do with AGI than my toaster oven does. Like it's not representing the knowledge in a way that will allow it to make consistently meaningful responses. And that's not to say that everything in there is totally useless for AGI. It's just that, like, you're not going to make GPT 4, 5, 6, 7 and get AGI. So I mean, there's very interesting work on tree transformers where you use like a constituent grammar to bias the generation of a transformer network. And then I've been playing with something like that where you use a whole knowledge hypergraph. You can use a knowledge graph, which is dynamically constructed based on what's been read, to guide the generation of the transformer. And then you have some semantic representation, some knowledge that's playing a role in the generative network. So I mean, I think,
and that's in OpenCog, right? Or that sounds like it's
yeah. So so there's some of the ideas and tools and transformer networks may end up being one component among others in a viable AGI architecture. But on the other hand, OpenAI is not working on those things, from what I know. I mean, from what I could see, their philosophy is mostly take the best AI out of the literature and implement it at very, very large scale with a lot of data and a lot of processors, and then it will do new and amazing things. And the thing with that is it's semi-true. Like that, there's so much in the AI literature that gave so-so results and will give amazing results once you run it on enough data and enough processor time. But you usually need to rejigger the architecture and rethink things and add some important new features while you're in the process of doing that scaling up. Like, so I was teaching deep neural networks in the 90s in University of Western Australia. I taught a class in neural nets, cross-listed computer science and psychology department back when I was an academic. We were doing like multi-layer perceptrons with recurrent backpropagation. We were teaching deep neural nets. And you could see you needed to scale up massively because you were running a neural net with like 50 neurons and it took all your processor time for hours, right? But the process of scaling it up, it wasn't like take that exact code and idea and run a lot more machines. Like still people aren't using recurrent backprop, right? They came up with with other methods. So at the very high level, I sort of do think we can get to AGI by taking ideas we have now and scaling them up on massive number of machines with a massive amount of data. But when you're in the weeds, that scaling up involves reinventing a whole bunch of new math and algorithms kind of in the spirit of what was there before. And I think OpenAI is so far sticking a little too closely to like, let's actually take what someone else invented and just literally scale it up on more machines with more data, right? And that's it leverages their position very well in that they have a lot of money, a lot of data, and a lot of computers, right? But I think we need. I don't think we need necessarily humongous conceptual revolutionary breakthrough to get to AGI, but I think we need more creativity than that, right? And so that leads on to my own AGI work, I guess.
Yeah, I was going to say maybe that gets us to OpenCog, to SingularityNet, and I think this is entangled too with the next question I did want to ask, which is what are some of the risks that you see coming from AGI? I know you've been generally more optimistic, maybe than some of the hardcore pessimists in the community, but you see some risks, and I'm curious how that plays into your own view about what the most promising route to AGI would be.
Yeah. I mean, there's two categories. Let me address the risk thing first, because once I start talking about OpenCog and true AGI, it's hard to stop. So I mean, there's two categories of risks in my view. So one risk is the sort of Nick Bostrom style risk, which is, you do your best to create an ethical AGI using all your math theory and your loving care and common sense and getting all the politics right, and then you still can't reduce the uncertainty to zero when you're creating something that's in the end more generally intelligent than you are, right? I mean, there's no matter how optimistic you are, like there's some odds that there's something you can't foresee that's gonna unfold there. And I mean, I don't buy Nick's argument that a superhuman AGI is going to intrinsically have a drive to turn us all into computronium to make more hard drive space for itself. I mean, the whole drive to be megalomaniac and consume all resources and squash your enemies. This is not something that necessarily is there in an engineered system by any means.
But isn't he looking at that as an instrumental goal though that emerges like
no, I
in
don't
the
think it
pursuit of
has
other
to
things?
emerge at all. No, I think that's bullshit. I mean, I think that emerges in systems that evolve through competition or through some complex mix of competition and cooperation. But if you're engineering a singleton mind, say, it doesn't have to, it's not competing with anything, right? It just doesn't, it didn't evolve in that competitive way. So it doesn't have to have that motivational system. So I don't think the drivers that cause humans to be that way have to be there for an AGI, because I mean, you and I could compete, but we can't merge our brains if we want to become a superorganism. Two AGIs that started competing could decide to merge their brains instead, right? I mean, so I don't think I don't think that logic applies to systems that are engineered and don't evolve in the way that we did. So, but on the other hand, I have to say there's an irreducible uncertainty in creating something like 100 times
Yeah.
smarter than me, right? I mean, it may, for all you know, it could immediately make contact with some even more super intelligent that's imminent in the quantum fluctuations of elementary particles that we think are
Right.
random, and that other AI that it contacted could be good or bad from a human point of view, right? So there's that. There's an irreducible uncertainty, which is really hard to put a probability on. And to me, I mean, there's also an irreducible uncertainty that I wake up in 5 seconds and realize like I'm a brain in a vat in some other universe, right? So that, I mean, there's irreducible uncertainties all around if you reflect on them. But then there's a more concrete risk, I think, which is that, I mean, humanity could develop malevolent or indifferent AIs in a pretty directly, simply comprehensible way, even before you get to massive super AI. And so this gets down to my oft-made observation that the main things that AIs are used for in the world today are selling, killing, spying, and crooked gambling, right? I mean, you're advertising, you're doing surveillance, military, and you're doing like Wall Street trading. And so if this is what's shaping the mind of the baby AGI, maybe it will end up being a greedy megalomaniacal sociopath reflecting the cognitive structure of the corporate and government organizations that gave rise to it, right? So I mean that's a palpable risk, right? I mean you could see if Earth AGIs are spy agencies, Wall Street traders, and advertising companies, which are exacerbating global wealth inequality. And then, I mean, you've got a bunch of people in the developing world who have no jobs anymore because robots in the developing world took their jobs. So they're being subsistence farmers and computer hackers, right? So, I mean, there's potential dystopic scenarios that don't need any super AGI, and that from some points of view would be even look like the most likely scenario given the nature of world politics and technology development, right? So
Which also
I mean
seems to kind of motivate your approach, right? I mean, the
yeah,
decentralized
that certainly motivates my approach, and I think this ties in with AI algorithmics in a subtle way that's not that subtle, but subtler than is commonly appreciated, because I think big tech companies, even the more beneficial oriented ones run by good-hearted human beings, they are focusing on those AI approaches that best leverage their unique resources, which is huge amounts of data and huge amounts of compute power. So if you look at the space of all AI algorithms, maybe there's some that don't need that much data or compute, and there's some that need a lot of data or compute. The big tech companies, they are sort of have a fiduciary duty to put their attention on the ones that require a lot of data and compute, because that's where they have more competitive advantage over everyone else. And they have such, if you're working in one of those companies, the APIs for leveraging their data and compute power are really slick and so much fun to work with. Like if you're working at Google, I mean, simple command and you're doing like a query over the whole web, like that's amazing, right?
Yeah.
So I mean, of course you've got a bias to use those tools, but the result is that the whole AI field is being pushed in a direction which is hard to do if you're not inside a big tech company. It's a valid direction, but there may have been other directions, I think there are, that don't need as much data or compute power, but those don't have nearly such slick tool chains associated with them. So for a developer like OpenCog, that I'll talk about in a moment, is kind of a pain in the ass to work with. TensorFlow is much easier to work with. That's not entirely for fundamental reasons, though. Like we don't have the UI developers. We don't have all the team that's needed to make parallelism scale up automatically, right? So the approaches the big tech companies have slicker tools associated with them, so they'll attract more developers, even out of the ones not working for those big tech companies. So what happens is, and of course, if you're a PhD student, if you write a PhD thesis that matches what a big tech company is doing, I mean, you're more likely to get a good job right away. So why not do that? It's also interesting, even though there's other interesting stuff. So the whole AI field is sucked into what's valuable for these companies doing, selling crooked gambling, spying, and supporting, murder activities by national governments.
It's funny
And
how common these effects are. I mean, I'm just thinking back to like my time in academe in physics, where I was studying interpretations of quantum mechanics. And it was like, that's like a great career ender. If you ever want a career ending thing to study, is like go into fundamental like quantum mechanics. And it's the same, anyway, it's sort of funny,
yeah, and that's an area I've studied a lot, and there's a lot of depth in the interaction between that and quantum computing. I mean, that's a whole other fascinating topic. And I think, reinforcement learning, it suits really well a company which has a sort of metrics oriented business model, and supervised learning does as well. So like if you're running an advertising company, sales of all kinds is all about metrics, like how big is your pipeline, how many deals have you closed, this advertising channel, like how good it has the ROI been, right? And
it's
so
like a clear reward function.
Wall Street obviously as well. One of the beautiful things about working in computational finance, I mean, I like it as a geek, it's cool because you get immediate feedback on what your algorithms are doing, as opposed to medicine where it can be years to get feedback. But because these business areas are metrics oriented, that's really driven AI toward things like supervised learning and reinforcement learning, where you're optimizing these quantitative metrics all the time. And it's not that that's bad or invalid, but it's not the only thing that you can do in advanced AI or AGI. So I mean, other things like, say, hypothesis generation, which is important for medicine or science, it's just nastier to quantify. Computational creativity in general. So like Google Deep Dream got a lot of news. It's creative compared to a lot of things, but in the end, it's just combining pictures that were found online, right? It's not that creative, but computational creativity, it's hard to put a metric on it. And AI development has been driven by, these metrics driven business models. Now there's some good about that, right? I mean, having a metric lets you cut through your internal bullshit in certain ways, and it can drive progress. On the other hand, it also drives progress away from valuable things. Like my mom spent her career running social work agencies, and she was always fed up by, these philanthropic organizations. They would only donate to nonprofits that were demonstrating progress according to metrics. But yet it's very, very hard to show your progress according to metrics if you're doing, say, enrichment education for low-income single mothers or something. I mean, the metrics unfold over years, and it costs a lot of money to follow up the people and see how they're doing. So the result there is philanthropic organizations prefer to donate to breast cancer or something, where you can quantify progress. So that this is the thing, is focusing on quantifiable progress is good, but it pushes you to certain things. And in AI, it's pushing you to reinforcement learning, where you're doing reward maximization, and it's pushing away from education, healthcare, and science, where things are it's harder to immediately quantify. That's what I see as a short-term danger. And in a way, focusing on the long-term Nick Bostrom danger is valid. In a way, it's a disinformation campaign to distract your attention from the short-term danger. So when a big tech company tries to get you to pay attention to super AGI might kill you 50 years from now, I mean, and sponsors conferences on that, partly it's a way of distracting your attention from the damage they're causing in the world at this exact moment, right? So there's a valid aspect to it too. So that, I mean, the world is very tangled up, right? So.
Yeah, it's funny how often problems come down to the fact that important things are often hard to measure. And when we score the functioning, for example, like the economy in terms of the stock market or GDP or some metric that's easily
GDP is going up a lot this quarter, right? I mean,
right. That's
very, very, very exciting.
What's the problem? Everything's great. Yeah.
Well, and you and I are probably doing okay, right? I mean,
Right.
I'm not complaining personally at the moment, but I can see, overall there's
It's a metric that fails to capture a lot.
profound economic issues, and I can
Yeah.
see like my sister's a school principal, and there's low income kids who are just sitting at home watching TV all day, getting no education, and there's going to be a lot of ramifications to that. But hard to measure. GDP going up is easy to measure. Huh?
Right. Now, I do want to kind of tack into sort of the last area I really want to make sure we can touch on, which is which AI risk mitigation strategies you think are most promising. I'm going to focus maybe on the short-term risk that you've highlighted in terms of
Well, let me say a little bit about my own AGI work now, because that will tie into that. So I think so my approach and my feeling since the late 90s has been that what I would call a hybrid approach to AGI is going to be most successful. And there were architectures in the 80s called blackboard architectures, where you had sort of there were blackboards back then. Now they're whiteboards, right? Or Prometheus boards. They have a lot of things. But so you have imagine a blackboard, and you have a bunch of experts in different areas, and they're all writing on the same blackboard, and they're all erasing what each other wrote, and they're collectively doing a proof or making a picture or something. So I think each of the historical AI paradigms, which I would say neural net, supervised learning, unsupervised learning, logical inference, and evolutionary learning, and a number of others. Each of these paradigms, in my view, is sort of like one of the blind men grabbing part of the elephant of intelligence. Like one guy's grabbing the nose, the other guy is pulling the ears. One guy is pulling on the others or something, right? So I mean, I think each of the traditional AI paradigms is getting at a key part of what we need for human-like general intelligence. And given that, so one approach is to try to find ways to make one AI paradigm incorporate what's good about all the other ones, right? So make a neural net do logical reasoning and do evolution. Another approach is to come up with some new meta algorithm that sort of incorporates what's good about all these different, and that's very appealing to me personally, actually. But the approach I think is probably going to succeed first is a hybrid approach, where you're letting algorithms coming from these different classical AI paradigms cooperate together in real time on updating a common knowledge base. And I think that work in that direction, ultimately it's going to lead to what looks like a single meta algorithm that incorporates the best of what comes from these different paradigms. But I think we're going to get there by actually hybridizing different algorithms from different classical AI paradigms and having them work together. So in OpenCog architecture, what we do is we have a knowledge hypergraph. So it's a weighted labeled hypergraph. Actually, it's a metagraph, not a hypergraph. Because
can you define those things?
Yeah, like I was about to. A graph has nodes with links between them, right? Okay. A hypergraph has nodes with links, but a link can go between more than two nodes. Like you can have a link spanning 3 nodes or something. A metagraph, you could have a link pointing to a link, or a link pointing to a whole subgraph, right? So it's like the most abstract graph that you could get. So OpenCog Atom Space, it's a weighted labeled metagraph. Weights means each node or link could have a set of different quantitative or discrete values associated with it. And labels, these are types associated with nodes and links. And so we don't enforce a single type system on the Atom Space, but you could have a collection of type systems on the Atom Space. So from a programming language view, it's like a gradual typing system or something, where you could have something untyped, or you could have something with a partial type, and then the types even new types could be assigned via learning. But you can have type checkers and that whole instrumentation on there. So it's a weighted labeled knowledge hypergraph, and then you allow multiple different AIs to act on this knowledge hypergraph, concurrently. and this is where things get interesting, because if you have a probabilistic logic system and you have, say, a tractor neural net, and you have a reinforcement learning system, and you have, say, a automated program learning system, these are working together on the same knowledge hypergraph, I mean, then you need them to be cooperating in a way that leads to what we call cognitive synergy, which sort of means they don't screw each other up, right? It means like basically if one of the algorithm gets stuck, the other algorithms should be able to help it overcome whatever obstacle it's facing. That requires the various algorithms to be sharing some abstraction of their intermediate state with each other. So it means some abstraction of the intermediate state of each algorithm as it's operating on the knowledge hypergraph needs to be in the hypergraph itself, right? So that, and this is where the design gets subtle, because doing everything in this hypergraph is slow, but doing nothing in there means you just have a multi-modular system with no ability for each algorithm to see the other one's intermediate state. So it's like what abstraction of its state, what portion of each algorithm's state goes in the hypergraph versus outside. And this, in a neural net, for example, we develop what we call cognitive module networks, where you say if you break a deep neural architecture into layers or something, you may have a node in the hypergraph representing each layer and its parameters, and the piping between layers happens in the hypergraph, but then the spreading of the back propagation inside a layer happens in some torch object that's outside the hypergraph.
Oh, so you're constantly bouncing back and forth between
but so the nice thing with torch is you have very good access to the compute graph, unlike in TensorFlow. So if you have two different torch neural nets, you represent them by nodes in the hypergraph. And if you compose those torch neural nets, that's represented by a symbolic composition of the nodes in the hypergraph. So if your reasoning engine comes up with some new way to compose neural modules, that can be backed out to composition in torch, and the compute graphs, the composition just passes through. So like in math terms, you have a morphism between the torch compute graph and the logic graph within the hypergraph, right? So that's but there's a lot to work out there, right? So I just described one little bit of it, which Alexei Polipov, who leads our St. Petersburg team, published, I guess, last year in a paper on cognitive module networks. But you need similar thinking to that, like pairwise for each pair of AI algorithms, right? And so like how does your evolutionary learning algorithm make use of probabilistic reasoning to do fitness estimation? And it's the hybrid approach, and it mostly has a steep learning curve, right? Because you need to understand this cross-cutting knowledge representation, and you have to understand all the algorithms that are playing a role in it. So where we're at now with that, actually, we came to the very painful and annoying conclusion that we needed to rebuild almost the whole OpenCog system from scratch. So we're
OpenCog 2.0. This is
we're calling OpenCog Hyperon. I decided to name the versions after obscure elementary particles instead of numbers. Like Linux has all these funny animals, or Apple has California's suburbs, right? So I mean, we're doing Hyperon. When we port to quantum computing, we'll make it Tachyon or something.
There you go.
So basically, it's about scalability. I mean, we can do whatever we want with the current OpenCog, but it's too slow in a few different senses. I think probably the most obvious thing is we need it to be massively distributed. Like now we can have a knowledge hypergraph and RAM on one machine, and we can have a bunch of hypergraphs share a Postgres data store in a sort of hub and spokes architecture, but we can't use the current system across like thousands or tens of thousands of machines. And ultimately, for our work with transformer neural nets, we have a pretty big server farm with all these multi-GPU servers. For OpenCog, we just can't use scalable infrastructure now, and it's obvious we need to. So part of our bet is, just as happened with deep neural nets, like when you manage to scale them up the right way, whoa, look at what they can do, right? So we're thinking that once we've scaled up the OpenCog infrastructure, we're suddenly going to see the system able to solve a whole bunch of hard problems that it hasn't been able to so far, right? So that's part of it, is just scaling up the knowledge hypergraph. And of course, that mostly means scaling up the pattern matching engine across the knowledge hypergraph, right? Because I mean, just scaling up nodes and links isn't that hard. Getting the kinds of pattern matching we need to do, which significantly go beyond what current graph databases support, getting the kind of pattern matching we need to do to scale up across a distributed knowledge hypergraph.
Yeah.
Not impossible, but it's work, right? Then the other thing is, and this is more interesting from an AGI point of view, from the work we've been doing putting neural nets, evolutionary learning, and logic together, we've just come to a much subtler understanding of how the knowledge hypergraph needs to work. So we're creating what's effectively a new programming language, which is we've been referring to atomies, because in OpenCog the nodes and links are called atoms. Atom is the superclass of the node and link subclasses. So we informally referred to the dialective scheme we have been using to create and manipulate nodes and links as atomies, because both nodes and links are atoms. So this is atomies 2. Maybe we'll come up with another name, but we're understanding better what we need to do in terms of a type system and then a sort of family of index type systems inside the M space to better support integration of neural nets, reasoning, and evolutionary learning. And so this has led us to dig fairly deep into Idris and Agda and various of these dependently typed programming languages. So we're looking at sort of how do you do gradual, probabilistic, linear dependent typing in a reasonably scalable way. And because it seems like if you can do that, then you can get these multiple AI algorithms we're working with to interoperate sort of scalably and cleanly. And this comes down to like how much of the operation of these AI algorithms can you pack into the type checker of like a gradual, probabilistic, linear dependently typed language. Because like the more of the AI crunching you can fit into the type checker, then you can just make sure that type checker is really, really efficiently implemented, right? And this ties in with which aspects of internal state of the AI algorithms are put into the knowledge hypergraph, right? So we're digging very deep into functional programming literature on that side, as well as into the distributed graph databases. And I think this may be how, in the end, hybridizing different algorithms eventually leads you in the direction of, well, actually, what I've ended up with bears little resemblance to the algorithms I started with, and we right. have a meta algorithm. So to start, OpenCog Hyperon will certainly be a hybrid. Like we're going to keep using Torch, or if something better comes along, right? And we're going to use our probabilistic logic network framework, and we can make those work together. But it may be that after a few years of incremental improvement there, like we've modified the neural, evolutionary, and logical part enough that you just have something you want to call sort of a different more abstract learning algorithm. Because when you cache these things out at the category theory level, I mean, the differences between a neural learning algorithm and a logic inference algorithm are much less than one would think when one looks at them at the current implementation level. So part of it is about having an implementation fabric where the underlying commonalities between the algorithms from different paradigms are exposed in the language rather than obscured, which is the current case.
Yeah, I was going to say that itself is really interesting, because I generally, at least I've seen it framed as an adversarial relationship, this idea of neural learning versus symbolic learning, or like symbolic logic. And what I find cool about this is you're really kind of fusing the two together and making them play nice in a very formal
way. And we've already done that in simple ways. So like, I mean we have for example, you have the nodes and links in the hypergraph, and you can do embedding to embed a node in a vector, right? And we do that. we tried deep walk and graph convolution networks. Actually, we're doing it using kernel PCA in a certain way now, some more traditional tools. But what you can set that up so that you have a category theory, like you have a morphism between the vector algebra of the vectors and then the probabilistic logic algebra on the graph side. Wow. So what's interesting, if you're trying to do logic inference, you have some premises, you have a conclusion that you want to derive or try to derive from the premises. You can make a graph embedding as a vector of the premises, make an embedding of the conclusion. So then you have a vector for the premises vector of the conclusion. You can look at the midpoint. You can look at sort of the intermediate points along that vector. You map those midpoints back into the knowledge hypergraph, and then you look at those as potential intermediate premises for the logic engine to do an inferring from the premises to the conclusion, right? So you're using the morphism between graph space and vector space as a method of logical inference control, right? And and that depends how you do that mapping, because if you just straightforwardly use deep walk or GCN to do the mapping, you don't get a morphism that's accurate, right? So there's a lot of subtle things there, and I think once I think we're going to get rid of back propagation, and as that is gotten rid of, you're going to see that replaced with algorithms that map more naturally into
between
things on the logic and evolutionary side also. So this is another subtle point, is playing around with InfoGAN and other more subtle neural algorithms. So we've got an InfoGAN, which is a form of GAN that learns automatically these semantic latent variables on the generative network side. We've gotten that to do transfer learning between clinical trials successfully, which is pretty cool. So like you train an InfoGAN network to sort of predict which patients in, say, a breast cancer clinical trial are going to be helped by which medication, and then using an InfoGAN for that, the semantic latent variables there can be used for patient segmentation in a way that lets you transfer to a different clinical trial better.
So a different clinical trial still on breast cancer, I assume, right?
Yeah, it'd be still on breast cancer, but maybe with different drugs.
Interesting.
Or maybe a very different patient population, right? It might be you can tell something even for different cancers. I mean, we're looking at tumor gene expression, and there's a lot of similarity between the tumor gene expression data in cancers in different tissues, actually. But we've been looking at breast cancer mostly because there's more open data about that than about other things. So that there we got it to work. But what I was coming to is, if you try InfoGAN on like video data or something, the learning just doesn't converge, right? And so then you give up and you're like, that's a bad architecture. But maybe it's not a bad architecture, and backprop is just a bad learning algorithm, right? So I'm suspecting that using floating point evolutionary learning like CMAES or something on these really complex neural architectures may work better. But if so, that gives you a lot to go on in cognitive synergy, right? Because once you're using an evolutionary learning algorithm, well, you can use inference for fitness estimation, right? I mean, there's a lot of openings for other AI tools in your hybrid system to help guide the evolutionary learning in a way that's more challenging in a backprop framework. So yeah, this is something I'm curious about, which is a purely technical point, like how many promising neural architectures are being discarded just because they're not suitable
for backprop.
For backprop, which is a very good algorithm, but has its strengths and weaknesses like everything else, right? So
well, maybe this ties in, at least thematically, with another kind of contrarian position, at least as you were saying earlier, with respect to, I guess, the way AGI is looked at, or AI is looked at, or intelligence looked at in the West, which is, so we tend to take just a materialistic view of consciousness. But I do want to touch on this idea of panpsychism that you've been a fan of, which is almost as controversial in the West as like discarding backprop is. Do you mind kind of elaborating a little bit on panpsychism and maybe its connection to some of your thinking on AGI? If
I will elaborate on panpsychism, but I have skipped the company I'm now the CEO of, which I must tell you about for a few minutes. So SingularityNet, which is on it. So I've talked a lot about OpenCog and OpenCog Hyperon, right? And that's something I've been working on a long time. Now, what I've been doing the last few years is leading this project called SingularityNet, which is it's a blockchain-based AGI platform, basically an AI platform, not just AGI, AI and narrow AI both. So that lets you basically operate a bunch of Docker containers, each of which has an AI algorithm satisfying a certain API in it. And then these Docker containers can coordinate together. They can outsource work to each other. They can rate each other's reputation. They can pay each other. And someone can query the network. And there's a peer-to-peer mechanism that passes the query along through the network to see if there's anyone who can do what that query asked for. But the whole thing works without any centralized controller, right? So it's a society of minds, as AI pioneer Marvin Minsky was talking about.
And why is that important, by the way? So why?
Yeah. So this ties back to the more political industry structure aspects we were talking about, right? Because it's important because as we move from narrow AI toward AGI, we're going to be a lot better off as a species if the emerging AGI is not owned or controlled by one actor, because any single actor is corruptible. And I'm not very corruptible, but if some thugs come to my house and threaten to murder my children if I don't give them the private keys to my repository, then I probably am corruptible, right? So I would rather not be in that position, or anyone be in that position, right? So I think we want the early stage AGI, as it evolves, I think we want it to be more like Linux or the internet than like, say, OS X or some company's private internal network. And to enable that is challenging, right? Because you're talking about like runtime systems that are using a lot of RAM and processing power and data and network and so forth. So SingularityNet is a platform that allows a bunch of different nodes in a distributed AI network to cooperate and operate in a purely decentralized way. And it's out there now. It's not as sophisticated as it will be. I mean, we're working with Cardano blockchain. Right now, it's implemented on top of Ethereum blockchain. We're moving a bunch of the network to Cardano blockchain, partly because it's faster and cheaper, but partly because we're introducing some more abstract features that Cardano supports better, because their smart contracts are in Haskell, which is a nice abstract language. So we're looking at how does one AI in the network describe at an abstract level what it does to the other AI in terms of the resources it uses, the data it takes and spits out, but also like what properties its processing fulfills. So we're introducing an abstract, like dependent type theory based description language for AIs to describe what they're doing to each other, which is supposed to make it easier for one AI to reason about how to combine other AIs to do something, right? So if we compare to OpenCog, in OpenCog you have this knowledge hypergraph and multiple AI algorithms are tightly integrated on top of it because they have to all understand what each other are doing semantically. Singularity is looser integration, right? You have multiple different AIs in the network. They communicate by a description language that tells what each other are doing and why and what properties they obey. But in the end, they can be black boxes. They can have their own knowledge repositories and exposing certain properties. So I think we want both of those layers. Like you want a society of minds layer with multiple AIs that are semi-transparent with regard to each other, and then within that, you'll have some things that are doing more narrow functions, like processing certain data types or doing certain kinds of optimization. And you have some AIs in that network that are serving more general intelligence type functions, just like we have a cortex, and we have a peripheral nervous system and the cerebellum and so forth. So in that landscape, OpenCog is intended to power the agents that run in SingularityNet network, doing the most abstract cognition stuff, but we want a lot of other things in there complementing them.
Because I was going to ask, how does the coherence then emerge from SingularityNet? It sounds like then it's like OpenCog gives you that coherence, gives you that high level reasoning, and then outsources tasks through SingularityNet, through the blockchain to other AI.
Yeah, and you can deploy OpenCog through SingularityNet, right? So I mean, you can have multiple different OpenCog agents running in SingularityNet, but it doesn't. From a pure SingularityNet point of view, OpenCog doesn't matter. Like people could deploy whatever they want in there. From the view of like why I personally created it in the first place, it's partly because you want a decentralized open way for your OpenCog systems to cooperate with a bunch of other things. So yeah, we SingularityNet is run by it's a nonprofit foundation. It's more like Ethereum Foundation. We've spun off a for-profit company called True AGI, which is sort of working on building systems using the OpenCog Hyperon framework. So that's sort of like a
cool.
like a Linux Red Hat thing, right? Where OpenCog Hyperon is open, but just as Red Hat commercialized stuff on top of Linux, True AGI is commercializing, or working toward commercializing systems that are built using OpenCog Hyperon and SingularityNet. So yeah, there's a lot of layers there, and this actually ties in with your questions about panpsychism and consciousness in some
emergence,
some indirect ways, because I think, yeah, part of the idea underlying panpsychism, which is the sort of the philosophical premise that, you know, everything is conscious in its own way, right? But just like in George Orwell's Animal Farm, all animals are equal, but some animals are more equal than others. I mean, in panpsychism, everything is conscious, but some things may be more conscious than others, or differently conscious than others, right? And so it's in that point of view, you know, it can seem ridiculous to say that this coffee cup is conscious, but yet if you dig into quantum field theory, I mean, and quantum information theory, at a certain level, I mean, all these wave functions, they're interacting with the wave functions that are outside this system. They're processing information all the time, and they're incorporating that in some aspects of global coherent state as well as local state. I mean, if you try to boil down consciousness to sort of information processing or like distributed coherent awareness, it becomes hard to argue that these processes are absolutely not there in some physical object, although you can certainly argue they're there to a greater degree in the human brain or a mouse's brain. But if you're talking about a philosophical principle, like is there a conscious versus unconscious dividing line, it's not clear in what sense that makes sense. Certainly, you can speak about abstract reflective consciousness, like self-modeling at a cognitive level, and we are doing that in a way that this cup is not, right? So there are some aspects of the natural language term consciousness that humans have and a coffee cup doesn't have. So what becomes subtle in thinking about consciousness is what Chalmers called the hard problem of consciousness, right? So we have various sort of empirical properties we could talk about, like, can you model your mind in a practical sense and answer questions about what you're doing, and are you exchanging information with your environment and registering that information exchange in your global state? You have all these sort of empirical properties associated with consciousness. Then you have what are called qualia, like the experience of existing, right?
Right.
And what many people do is they correlate the experience of existing with sort of reflexive self-modeling, which the human brain clearly does in a way that a coffee cup doesn't. And I think the key aspect differentiating panpsychism from what's a more common view of consciousness in the modern West is, as a panpsychist, you tend to think like the basic qualia, the basic experience I am, is not uniquely associated with like reflective, deliberative, self-modeling type consciousness, but is rather, it's associated with the more basic, like information exchange type consciousness that is immanent in every physical system, right? And so that's not incredibly relevant to the everyday AI work that I'm doing now. It will become relevant when you start, you know, building femtoscale quantum computers, or maybe even simpler quantum computers. It'll certainly become relevant when you start doing brain-computer interfacing. But then you can ask yourself questions like, okay, this this computer that I've like wired into my head, right? Do I feel it there on the other end in the same way that I feel
Yeah.
it if I wire another human brain into my head? Or does it feel like what I get when I wire a coffee cup into my head, right?
Yeah.
Because I'm guessing if I wire a coffee cup into my brain or Wi-Fi it, I'm not going to feel that much of what it is to be a coffee cup.
Yeah.
I guess if I wire my brain into yours and increase the bandwidth, I will feel a lot of what it is to be you, which will be weird, right? What if I wire my brain into like our version 3.0 of our Grace Awakening Health, like elder care robot, right?
Yeah.
Well, will I feel, what it is to be an elder care robot? Will it feel something like what it is to be a human? Or will it feel like what it is to be a coffee cup, right? So I think that the rubber will hit the road with this stuff. And very interesting in terms of, say, something like SingularityNet as a decentralized society of minds, or even think about human society and the global brain of computing and communication and human intelligence cloaking the earth right now. I mean, one could argue the real intelligence is in human society and culture, and we're all just like neurons in the global brain, like responding to what it sends us on the internet, right? But what kind of consciousness or experience does the global brain of the earth, or would, say, a decentralized SingularityNet society of minds have, right? Like so in a panpsychist view, you might say, well, an OpenCog system, it has a focus of attention, it has a working memory, its conscious experience will be a little more like human beings, although quite different, because it doesn't grow up with a single body that it's uniquely associated with. Something like a decentralized SingularityNet network, might have its own general intelligence in a way that exceeds an OpenCog or a human. Its conscious experience would just be very, very different, right? I mean, because it's not centered on a single knowledge base, let alone a single body. And this gets back to your first question of like, what is intelligence, right? Because our whole way of conceptualizing intelligence, it's overfitted to organisms like us that we're here to control a body and get food and get sex and status and all the things that we do. An OpenCog system, even though it's very mathematical, ultimately it's built on the metaphor of human cognitive science, right? You got perception, action, long-term memory, working memory. I mean, it's because that's what we have to go on, right? But is that kind of intelligence greater in a fundamental sense than that which would emerge in a SingularityNet network that might, get some self-organized emergent structures that we can't even understand? And this brings us back to Weaver's notion of open-ended intelligence, right? So SingularityNet, you would say, is more of an open-ended intelligence approach toward AGI, where you're like, everyone around the world, put your stuff in there, have it describe what it's doing using an abstract description language. If it's going to flourish, it should get a lot of its processing by outsourcing stuff to others in the network rather than being solipsistic. And then, it's trying to make money by providing services. It's hopefully providing its creator with some money, helping with income inequality if they're in a developing country. But what does this whole thing develop into? No one's scripting it, right? So that's also very cool. So if the breakthrough to AGI happened in that decentralized way, would be really awesome and fascinating. I mean, the OpenCog way is a little more determinate. Like, we're architecting a system sort of modeled on human cognitive science. We're going to use it to control these elder care robots, which even have human-like bodies, like through a partnership of True AGI and the robot company. And so I mean that's a little more determinate, and it may be a little of each, right? We don't know how this is going to evolve, because the robots are going to draw on SingularityNet AI, including OpenCog plus other stuff on the back end. And from the robot's point of view, it will just draw on whatever works best for achieving its functions. And we'll see to what extent that's OpenCog versus some incomprehensible, like self-assembled conglomeration of 1,000 agents, right?
Well, it's a beautiful and exciting vision, and a very open-ended one too, which is kind of interesting. I guess we'll all have to kind of wait and see how this develops.
Yeah, vision is one thing. Making it work is what I'm spending
Yeah,
most of my time on, which is really astoundingly difficult. But it's amazing the tooling that we have available now. Like you couldn't have done this you could have written it down when I started my career, but each step would have just been so slow in terms of compute time and human time using the crappy tools available at that time. So it's amazing. This is all very, very hard, but it's amazing that we can even make progress on it now, right? So it's
yeah.
certainly
Well,
a fun time to be doing AI, as you and all your listeners know. Right?
absolutely, yeah, and it's a great time to be learning about things like this too, all the different approaches to solving this problem. Thanks a lot for sharing yours with us. Do you have any places where you recommend people go if they want to contribute to OpenCog or SingularityNet
Yeah,
or
yeah,
whatever to learn?
absolutely. So probably our best developed media property is the Singularity Net. So if you go to singularitynet.io, you can and look at the Singularity Net blog and Singularity Net YouTube channel, which is linked from singularitynet.io. Like that will lead you to everything. But regarding OpenCog in particular, there's an OpenCog wiki site, and you can find by go to opencog.org, then go to the wiki, and there's there's a page of stuff on OpenCog Hyperon, which is our new system. There's the current OpenCog is in GitHub. It's all open. And while I've been thinking a lot about the new version, the current version is what we're using inside these nursing assistant robots now. Like it does something. And there are two online conferences that I organized earlier this year, which might be interesting. So one was the OpenCog Con online conference, which is just about OpenCog. Then every year since 2006, I've led the Artificial General Intelligence Conference, which has been face to face until now. But this year, the online AGI 20 conference, you can find all the videos and papers from that online also, and that's some of my stuff, but also other things from the modern AGI community that I haven't had time to go into here.
Well, great. Thanks so much. Really appreciate it. It's something I'm sure a lot of people want to check out. And Ben, thanks so much for making the time.
Yeah. Well, thanks for the interview. It's a good fun. There's always more to cover than you possibly can, but there's some fun conversation.